Hello, Energy 101. We're talking about laws of nature, controlling the energy conversion, and we're deep into the second law of thermodynamics, or the second law of energy conversion. We've talked about energy quality, which is really a result of the second law, but this is probably the most difficult aspect of this whole course, Energy 101. But it's one I feel strongly about, that we have to talk about, because it's the one that people don't understand when they come to me about new technologies, the processes they feel they've come up with that will solve our energy crisis, because they don't it violates the second law of thermodynamics most frequently. The first law, a lot of time, most of us have some concept of that, and it's fairly easy to grasp. But the second law, being a negative statement that we've talked about, is more difficult. So stay with me here, and this is the last one on the laws of energy conservation, first and second law. But I want to give you a little bit of feel for those. Excuse me. I want to give you a little bit of feel for those so that you'll know when I say what you can and can't do from the laws of nature, you'll understand where it's coming from. And of course, this is the laws controlling the conversion of energy from input when we convert it to a different form at the output. And you've seen this before. We went through this example about energy quality, which is inherent in the second law that we would need to talk about again today. But just showing that example, quickly reviewing it, if we have waste heat or any heat that's available at 240 degrees Fahrenheit, then the quality we can calculate of that thermal energy comes out to be 20.29. That means it has a value per unit of energy of approximately less than 30% less than what work at that unit of work would have, or a unit of electricity, or a unit of potential energy, or a unit of kinetic energy, all of which have a quality of 1. So we're not going to pay as much for it, because it's not only has lower value from the thermodynamic sense, that means it has lower economic value. It filters through the system. So that's the example that we had. And the second law, as I briefly put it up last time, tells us that the fraction of the thermal energy, Q, that can be converted to work has to be less than the quality of that work. So since the quality of 240 degree Fahrenheit thermal energy is 29%, that means that the fraction of the thermal energy produced by whatever is producing the 240 degree Fahrenheit thermal temperature that can be converted to work is less than 30%. Now that's a ceiling. Notice you can't get 29% out, because the real world has friction in it. We have temperature drops that transferring it through heat exchangers and fluid flow through pipe friction that we have to pump it, that is not reversible. So what the second law does is put a ceiling on it. It doesn't say we can do that well. It says we cannot do better than that, and in real world we actually can't do that well because of the real world irreversibilities, we call it. So that's what the second law tells us, is that thermal energy is not of equal value to work, and we can convert thermal energy to work. We cannot convert 100% of it, and that's what I'm showing graphically right here. So here we got thermal energy at some temperature coming in with some quality over on the left-hand side, and I show a theoretical process that upgrades that thermal energy. Quality is a vertical scale here. The higher up we are, the higher the quality is. And the second law, I've got an X through it saying you cannot take that 1 unit of thermal energy and convert it to 1 unit of energy with a quality of 1, like electricity or work. Now, and this is, so many times I read it in the press, I see it on the national news, the fact that why are we wasting all of this energy at a power plant? Why aren't we using all of this heat, thermal energy that we're paying for in coal and natural gas and nuclear thermal energy? why are we taking that thermal energy and only converting a fraction of it into electricity and then throwing the rest of it away to the atmosphere of the rivers? Well, it's because the second law tells us we cannot do that. Why can't we do that? Why does gravity pull down? I don't know. But we've known it for 150 years. When people say that, well, they found a way around the second law of thermodynamics, I tell them they got to go talk to somebody else, because I firmly believe in the second law of thermodynamics. It served me well and has used it to design many, many energy systems of all types and new technologies, and it always works. It's worked for 150 years, and we don't expect to see that happening, like we don't expect to see the laws of gravity repealed. So that's a statement of the second law. So you say, well, how do we get thermal energy to produce converted to electricity? Well, what the second law does allow, it is upgrading some of the thermal or heat energy while downgrading the remainder, which is exactly what a power plant does. So here again, a similar diagram where the higher quality is on the vertical scale here, and we have combustion energy or nuclear reaction from uranium that produces thermal energy, and we put it into a power plant. I've taken an example here of 3 units of energy, or 3 BTUs, 3 kilojoules, take whatever unit you want. I've taken BTUs here. Could be million BTUs. And we put it through a power system. This is a coal-fired power plant. It's a natural gas-fired power plant. It's a nuclear power plant that is taking that thermal energy. We do produce about 1 unit of electricity out of 3 units of thermal energy to electricity. What happens to the rest of it? The rest of it we have to downgrade. Now, we can't get rid of the energy, we can't destroy energy, so we've got to throw it away. And we throw it away to the river, generally, or to the atmosphere. More and more we're throwing it away to the air rather than the rivers, because heating the rivers up damages the biological growth in the river and kills fish and etc. But it has a zero quality. So people say, why don't we utilize this energy? The same reason we don't utilize all the thermal energy in the atmosphere, because it has no quality, it has no value. But this is what the second law does allow. That's the way, is that if we downgrade some, we can upgrade others. And the limit of what percent we can upgrade is the quality of this energy. Before, if this was 240 degrees Fahrenheit, we could upgrade theoretically as much as 29% of that and throw away the other 71%. But that's the limit that the second law places on us, and the real world processes, we can't do that well. We try to approach it, and we spend more money on the power plants. We can get a little closer to it, but that's what the second law of thermodynamics does. And I've talked about power plants, but it's also true for auto engines, because they take in combustion heat and produce work to drive our rear wheels. Diesel engines fall into this category, and power plants. All 3 of those kinds of energy conversion systems convert thermal energy to work or electricity. And the second law limits what fraction of that thermal energy we can convert. That's just the way life is, and may not be the way we like it, but that's the way the natural laws have worked out, and that's what's been given us. So thank you. That's notice that I've talked about the second law of thermodynamics and never talked about something called entropy, because entropy is a very abstract quantity and property, and you don't need to know anything about it unless you get deep into the theoretical calculations of thermodynamics that we don't need to deal with in this course. Thank you.